The Juno spacecraft's last perijove, or closest point to Jupiter, resulted in a treasure trove of images. Its next perijove is coming up on December 26. Get updated here, and view Juno's latest amazing images. Jupiter's south pole as seen from the Juno spacecraft on November 4, 2019. These swirling spots are cyclones at Jupiter's pole. The whole hexagonal arrangement of cyclones is large enough to dwarf the Earth. The central cyclone can be compared to the continental U.S. The smallest one, in the lower right, a new one, seen for the first time in November, can be compared to Texas. Image via NASA, JPL Caltech, SWRI, AUSI, INAF, JIRAM. The Juno spacecraft, which has been orbiting the giant planet Jupiter since July of 2016, acquires close-up images of the planet at every perijove, or closest point to Jupiter. That happens about every 53 days. The batch of images acquired by the craft in early November, when it swung to within 2,175 miles (3,500 kilometers) of the cloudtops at Jupiter's south pole, are particularly mind-blowing. The big news for the November flyby, the craft discovered that Jupiter's south pole has 7 large, well-defined cyclones now, instead of the 6 seen previously. These cyclones appear in a hexagonal, 6-sided pattern at Jupiter's pole, rather than the pentagonal 5-sided pattern seen previously. A statement from NASA explained, "When Juno first arrived at Jupiter in July 2016, its infrared and visible light cameras discovered giant cyclones encircling the planet's poles, 9 in the north and 6 in the south. Were they, like their earthly siblings, a transient phenomenon, taking only weeks to develop and then ebb? Or could these cyclones, each nearly as wide as the continental U.S., be more permanent fixtures?" With each flyby, the data reinforced the idea that 5 windstorms were swirling in a pentagonal pattern around a central storm at the South Pole and that the system seemed stable. None of the 6 storms showed signs of yielding to allow other cyclones to join in. Then, during Juno's 22nd science pass, a new, smaller cyclone churned to life and joined the fray. Alessandro Mura, a Juno co-investigator at the National Institute for Astrophysics in Rome, said, "Data from Juno's Jovian Infrared Auroral Mapper (JIRAM) instrument indicates we went from a pentagon of cyclones surrounding one at the center to a hexagonal arrangement. This new addition is smaller in stature than its 6 more established cyclonic brothers, it's about the size of Texas. Maybe JIRAM data from future flybys will show the cyclone growing to the same size as its neighbors. Jupiter's pentagon turns hexagon. In this annotated infrared image, 6 cyclones form a hexagonal pattern around a central cyclone at Jupiter's south pole. That's in contrast to the 5 cyclones in a pentagonal shape seen previously." NASA, JPL Caltech, SWRI, AUSI, INAF, JIRAM. To give some sense of the immense scale of cyclones arranged in a hexagonal pattern at Jupiter's south pole, an outline of the continental United States is superimposed over the central cyclone and an outline of Texas is superimposed over the newest cyclone. The hexagonal arrangement of the cyclones is large enough to dwarf the Earth. This JIRAM image was obtained during the 23rd science pass of the Juno spacecraft over Jupiter, on November 4, 2019. Image via NASA, JPL Caltech, SWRI, AUSI, INAF, JIRAM. NASA said the flyby also marked a victory for the mission team, whose innovative measures kept the solar-powered spacecraft clear of what could have been a mission-ending eclipse. To understand what happened, you have to go back to Juno's entry into orbit around Jupiter on July 4, 2016. It was meant to enter an initial 53-day orbit, then reduce the size of its orbit a few months later, in order to shorten the period between science flybys to every 14 days. But the project team recommended to NASA to forego the main engine burn due to concerns about the spacecraft's fuel delivery system. Now Juno is carrying out its mission, NASA said, although it's taking longer than originally planned. But Juno's longer life at Jupiter is what led to the need to avoid Jupiter's shadow. Steve Levin, Juno project scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, explained. Ever since the day we entered orbit around Jupiter, we made sure it remained bathed in sunlight 24/7. Our navigators and engineers told us a day of reckoning was coming, when we would go into Jupiter's shadow for about 12 hours. We knew that for such an extended period without power, our spacecraft would suffer a similar fate as the Opportunity rover, when the skies of Mars filled with dust and blocked the sun's rays from reaching its solar panels. NASA explained that, without the sun's rays providing power, Juno would be chilled below tested levels. The space scientists believed that, during this time, Juno's battery cells would be drained beyond recovery. So the navigation team devised a plan to jump the shadow, maneuvering the spacecraft just enough so its trajectory would miss the eclipse. NASA said. The navigators calculated that if Juno performed a rocket burn weeks in advance of November 3, while the spacecraft was as far in its orbit from Jupiter as it gets, they could modify its trajectory enough to give the eclipse the slip. The maneuver would utilize the spacecraft's reaction control system, which wasn't initially intended to be used for a maneuver of this size and duration. On September 30, at 7:46 p.m. Eastern Daylight Saving Time, 4:46 p.m. Pacific Daylight Saving Time, the reaction control system burn began. It ended 10.5 hours later. The propulsive maneuver, 5 times longer than any previous use of that system, changed Juno's orbital velocity by 126 miles per hour, 203 kilometers per hour, and consumed about 160 pounds, 73 kilograms of fuel. 34 days later, the spacecraft's solar arrays continued to convert sunlight into electrons unabated as Juno prepared to scream once again over Jupiter's cloud tops. Scott Bolton, Juno principal investigator from the Southwest Research Institute in San Antonio, explained. The combination of creativity and analytical thinking has once again paid off big time for NASA. While the team was trying to figure out how to conserve energy and keep our core heated, the engineers came up with a completely new way out of the problem: jump Jupiter's shadow. It was nothing less than a navigation stroke of genius. Lo and behold, first thing out of the gate on the other side, we make another fundamental discovery. As you read this, Juno is heading toward its next perijove on December 26, 2019. Watch for news and new images shortly after the new year dawns. Please subscribe our YouTube channel Listen News Here. If you like the video, please like, comment and share the video.